Okay, in this sample exam question, here's the scenario. During a post-incident review, you determined that an attacker executed an ARP poisoning attack. Okay, so we're being tested here on whether we even know what that is, which is going to be important. Now remember, ARP cache poisoning means that a malicious actor is essentially sending out ARP cache update commands on the network to victim devices saying, hey, you might already have an IP address, let's say for the default gateway, in your ARP cache in memory, but I want you to update the MAC address to this. The MAC address being the layer 2 hardware address, and that, in this case, would be the MAC address of the attacker machine. The attacker does this because he or she would like to redirect network traffic, in this case, normally going to the default gateway, to first be directed to their device. This way they can see all network traffic. And then ideally the attacker would configure their device to forward on the traffic through the real default gateway. So it's completely transparent to victim devices. And the last thing we want is for attackers to be able to see all network traffic. Okay, so that's what the ARP poisoning type of attack is about. So the question becomes, which mitigations would be most effective in preventing this from occurring in the future? Let's take a look at the answers. There are two of them. A, network access control. Network access control is a security mechanism where you make it very difficult for an attacker to even get on the network in the first place, whether it's wired or wireless. Now, how is that done? Well, as an example, with a wireless network, a Wi-Fi network, instead of just requiring a pre-shared key to be entered to authenticate to the wireless network, maybe radius authentication is being used. And radius authentication just means that the authorization to allow network access is actually done by a centralized radius server. Not just the authorization, the initial authentication. Instead of that, the wireless router would forward the request to a centralized authentication server, and then if the user entered in their credentials correctly, they would be allowed access to the network. That's one way to mitigate ARP cache poisoning attacks. Disabling network broadcasts is just out of the question. Certainly with IPv4, a lot of the nature of how things work, how hosts are discovered and so on, including how ARP works itself, is by sending out network broadcasts. So we can't disable that. C, Spanning Tree Protocol, STP. This is a network switching solution that mitigates not ARP cache poisoning, but things like bridging loops. That doesn't apply. D, Static ARP cache entries. So what this means is that we can manually add ARP cache entries on devices, ideally using scripts. For example, in Windows, you could use the ARP-S command, S for static, and add the mapping between an IP address and a MAC address. And then that way it won't be overwritten when ARP cache updates are sent over the network.